But Josefa is also saying coordination compounds. Okay, you can lower your hand, guys. You can lower your hand. Okay, write the topic. The chapter's name is coordination compounds. Okay, please write. Coordination compounds are molecular compounds formed by combination of two or more simple stable compounds. And they retain their identity in solid as well as aqueous state. You can also write in bracket dissolved state. Now see, for example, how this concept of coordination compounds was discovered. We have NiCl2, and most of these discoveries, these are generally accidents. I have NiCl2. Okay, and NiCl2, it is green in color. Okay, and if I add here ammonia, then we got a compound which was purple in color. Okay, this was purple in color. Okay, now on evaporation, this is in liquid state, and when we are going to evaporate it, on evaporation, this liquid will get converted into crystals, and we got purple crystals also. We got purple crystals also. Then dissolved state as well as in solid state, the identity was maintained. That means the color was coming from a particular compound, and that compound maintained its identity in the solid state. That means in crystalline form, as well as in the dissolved form. Now, this particular molecule was found out to be nickel NH3 whole 6, and it had 2 chlorines outside the square brackets. Okay, and this was giving the purple color. Now, this is a very special type of molecule. This is a very special type of compound, and in this compounds we have central metal atom, which is surrounded by ions or molecules beyond their normal valence. For example, nickel has a valency, general valency of +2, but as you can see, it is bonded with 6 ammonia atoms. Okay, sorry, 6 ammonia molecules. Now, this is showing coordination greater than its valency, and that is why this was known as coordination compound, and it was a very special class of compounds. Please write. These are special class of compounds in which central metal atom or ion is surrounded by ions or molecules beyond their normal valency. Now, there is another class of compounds which are kind of similar to the coordination compounds in terms of its preparation. That means these are also prepared by combining 2 stable molecules or 2 stable compounds. These are known as double salts. So write the thing about double salts. We should also know what coordination compound is not. So coordination compound is not double salt. Double salt and coordination compound, they differ with each other. How do they differ with each other? Double salt, they have their identity in the crystalline form, the solid form, but as soon as you dissolve it inside water, they are going to lose their identity. But coordination compound, they maintain their identity even in the dissolved state. Please write. These are addition compounds which are formed by two saturated compounds but they lose their identity when dissolved in water. There is a thing which is known as potash alum. Okay, in Hindi we call it fitkari. I don't know whether you remember from 10th standard or not. In 10th standard, you must have learned this formula for potash alum. K2SO4 dot Al2 SO4 whole size dot 24H2O. Okay, so this water is already inside the crystalline. Okay, so water is a form of water is inside the crystal. It is a part of the crystal. When you dissolve it in water, then you get K plus ions, you get Al 3 plus ion, and you get SO4 2 negative ion. As you can see, this complete identity has been broken, and the color also, it is not going to be maintained if you have a double salt with some color, and as soon as you are going to dissolve it, the color is not going to be maintained in the dissolved state. Okay, so this is the difference between double salt and the coordination compound. I will list out the differences between coordination compounds and the double salt. You will copy it down. Okay, right till here. Also, write this down, normal valency and this primary valency and secondary valency. I will discuss it after a while, okay? But write that down right now only. Raise your hand once you're done. Raise your hand once you're done writing the difference between double salt and coordination compound. What about others? Ahmed, Huzaifa, Jiva, Sahel, and Zan. Are you guys done writing this? Okay, Zan is done. Waiting for Ahmed, Huzaifa, Jiva, and Sahel. Just waiting for you, Ahmed. Please let me know once you're done. Others, you can lower your hand. Okay, Ahmed is also done. Okay. See, next is the Werner's theory. First, I will explain the Werner's theory. I mean, what are the experiments that he did, what are the conclusions from that experiment, and how he approached those results from the experiments. Okay. So he was the first one who got into this field of coordination chemistry. And what he did was initially he mixed a lot of cobalt chlorides with NH3. So he started with cobalt chloride and added a lot of NH3. Okay. So he got a compound which was yellow in color. Then he started, now initially the NH3 was in excess, he got yellow color. Then he reduced a bit of amount. Still it was still what like almost excess only, and that's why it was yellow in color. Then he measured, like slowly he decreased the amount of NH3, and he found out that when he was using 6 for each cobalt chloride, if he was using 6 moles of NH3, then he was getting a yellow color compound. Then he said, okay, fine, let me reduce it furthermore, COCl3 with 5 moles of NH3. So he did a lot of experiment with this, and always he was getting purple color. Then he did COCl3 plus 4 NH3. So with this experiment, he got sometimes green color and COCl3 with 4 NH3. A few times he also got violet color. Now all of these will be having some chlorine because COCl3 is there and he is adding NH3. So he would be getting some chlorines here. So what he said that, okay, fine. If I will have Cl negative and I react this Cl negative with AgNO3, then this Ag is going to react with Cl negative and it is going to form AgCl. It is going to form what? AgCl. So in the first experiment, when he did COCl3 plus 6 NH3, he got 3 moles of AgCl. In the second purple one, he got 2 moles of AgCl. For the third case, he got 1 mole of AgCl. And in the fifth one, he got 1 mole of AgCl also. Now, from this experiment and from these results, he said that, okay, that means the first compound, which was yellow in color, it had 3 Cl negatives, right? It had 3 independent chlorine molecules. The second one had 2 independent chlorine negative. This one had 1 independent chlorine negative, and this also had 1 independent chlorine negative. That means this chlorine negative was in ionic state. That is why this Ag molecule, the silver Ag plus silver ion, was able to attack on this Cl negative and form AgCl. The first one gave 3 moles of AgCl, second one gave 2 moles, and the green one gave 1 mole, and the violet one also gave 1 mole of AgCl. He said that, okay, fine. That means I can categorize a few more things. He said that the first compound, which was yellow in color, it would have a formula which would be something like this. It would be having cobalt and NH3, and there will be 3 Cl away. In the second, there will be 2 chlorines that will be what? Independent. There will be 1 chlorine in the fourth one and 1 chlorine in the fifth one. So he predicted this will be the formula. He predicted this will be the formula. Then he said that, okay, fine, I can also see something. When I am having 6 NH3, then I'm getting 3 AgCl. That means all of these chlorines, please Listen very carefully. All of these chlorine molecules, all of these chlorine ions, the chloride ions, they are getting outside and they are independent when I have 6 NH3. When I have 5 NH3, out of these 3, only 2 are independent. That means one of the chlorine is inside here. One of the chlorine is inside, and rest what do we have? NH3s. So all of these NH3 is here. In this, the first case, the yellow case, only NH3 is inside, and chlorine, all the 3 chlorines are outside. In the fourth case, what will happen? CO, Cl2, and there will be 4 NH3. Fifth case also CO, Cl2, and 4 NH3. Now with this, he gave an idea about primary valency and secondary valency. For primary valency, as you can see, cobalt here, cobalt you can take it as X. NH3 is what? NH3 is going to be neutral, that is why it is 0. And chlorine is going to be what? -3, because each chloride ion will have a negative charge. 3 chloride ions will give you 3 negative. Now this will completely be equal to what? If I add X plus 0 plus 3, it will be equal to 0. That means X will be equal to +3. So in the first case also, X is equal to +3. Okay. And the secondary valency, he said that secondary valency is the number of molecules or number of ions around the central metal atom. So this cobalt is having 6 NH3, and this is the secondary valency for cobalt. Now in the second case, Cl will be 1 negative, and here we have 2 chlorine, that will still be +3. And the secondary valency is still here, how much? 6. Here also +3. In the third case, and this will be +6. This will again be +3, and this will be +6. Okay. So this is the concept of primary valency and secondary valency. All of you understood this? Yes or no? Please tell me. The experiment, the result, and the conclusion from the result. Yes or no? Please tell me.
Yes.
Anyone? Any doubt? Please tell me now. But try to understand first. ठीक है ना? As much sir फिर से explain कर दीजिए. Try avoid saying that. Okay. Try to understand at first, and then point out where you are not understanding, which part you are not understanding. Okay, that will help you. Anyone?
So one doubt, sir.
हाँ जी बताइए.
So आपने ऊपर लिखा है कि 3AgCl 2AgCl then 2Cl minus 3Cl minus. Is it like plus? It's like उसके साथ अलग से product form हुआ है या फिर?
नहीं product नहीं form हुआ. I was saying that time ना. What I was saying that time जब हम ऐसे बना रहे थे यारो. क्या बोल रहे थे? I was saying that this means this yellow molecule, it had 3 independent chlorine negatives. This purple molecule was having 2 independent chlorine negatives. This green and violet were having 1 independent chloride ions. Got it? Yes, Sahel?
Yes, sir.
I was just explaining that. That's not a part of a reaction. Okay. Okay. Now, write postulates of Werner's theory. आई थिंक ये जितने भी दमाम वाले हैं, आप लोग का ये पहला क्लास है ना एग्जाम के बाद? हाँ, सहल, समायरा. Sahel, you're also in Dammam, right?
Yes, sir. First class.
Samaira, आपका भी ना?
Yes.
How was the chemistry exam?
Sir,
Question
it
paper
was fine.
It was fine. कहाँ दिक्कत हुई?
So the numericals
Numericals में दिक्कत हुई. अच्छा.
and some part of theory also.
Send me the question paper. I think exams are over, right?
Yes. Sir.
Computer science बचा हुआ है शायद बस. Computer science is tomorrow, right? You guys don't have computer science. Okay. Send the question paper, okay, Samaira. What about you, Sahel? How was your exam?
Not too bad, sir. Not too bad. It's okay.
Not too. Why? कहाँ दिक्कत कहाँ हुई है आपको?
No, it wasn't that like दिक्कत एक जगह पे नहीं, like it was like I knew the answer, like आधी आंसर हर क्वेश्चन मालूम तो था हर क्वेश्चन का, बस कहीं ना कहीं एक पॉइंट ऐसे मिस हुआ ऐसे लगा.
Okay. Both of you will be getting the same paper, right? या फिर लड़के लड़कियों का अलग होता पेपर?
Not sure, sir. Last time
Not
it wasn't the same.
Last time it was not same ना? जब हमको
हाँ,
reveal
और
किया.
टाइमिंग भी अलग कर दिया था, मतलब होता 1 घंटे से हमारा अचानक से 40 मिनट कर दिया लास्ट
Oh.
टाइम.
Okay. Send the question paper, okay? Then both of you. Samira, you also send, and Sahil, you also send.
Okay, sir.
Right. In coordination compound, metal exhibits coordination compound. Metal exhibits two types of valency. Number one, primary valency, which corresponds to which corresponds to which corresponds to the oxidation number of the metal atom and is satisfied by negative ions. Right, second point, secondary valency. So secondary valency, it corresponds to the coordination number. That means the number of ligating atoms or the coordinate bond that has been formed between the metal atom and the ligand that is present surrounding the central metal atom. Is it? Secondary valency. Secondary valency corresponds to the coordinate bond, sorry, coordination number of central metal atom or ion and is satisfied by negative ions or neutral molecules. The second point, secondary valency is always directed towards the fixed position in space and this leads to definite geometry of coordination compound. Then write the question. Raise your hand once you're done writing the question. Write the question and then raise your hand, please. Acha, okay, Josefa. Fine. So listen, all of you. On the basis of the following observation made with accurate solutions, write the formula. So first of all, you have to write the formula and assign secondary valency to the metal atom. Secondary valency is what it is inside that square brackets. Okay, whatever you write inside the square brackets, that is the secondary valence. Primary valency is outside whatever ions are present outside the square brackets. First thing is that you have to write the formula. Now, in all of these things, you can see that there are chloride ions, right? COCl3, PdCl2, NiCl2, PtCl4, PtCl2. In all of these things, we have chloride ions. And if I have chloride ions, and if the chloride ion is independent, then it is going to form what? It is going to form AgCl. So in the first case, how many chlorides are independent? Tell me. If I am getting 1 mole of AgCl, then how many chlorine atoms, or rather I should say chloride ions, are independent? Yes, Jiva, Sahel, Samaira, Zan, and Ahmed, tell me.
3.
In the first case, how many is independent? Tell me. 3 chlorides, right? Sahel?
Yes, sir.
Okay, if 3 chloride ions are independent, and if I'm going to add AgNO3, then how much AgCl will be formed? How much AgCl will be formed? Tell me.
In terms of mole, right?
In terms of moles only.
1 mole.
Why? I have 3. So why I will form 1? This is excess of AgNO3 is present. Huh? I have so much amount of AgNO3 present already. So how much AgCl will be formed? Tell me.
3 moles.
3 moles, right? But how much is forming?
1.
1 mole. आपको ये बताना है. You have Cl negative, some number of Cl negative independent, and you are adding AgNO3, which is excess. In the first case, you are getting 1 mole of AgCl. That means how much chlorine will be there? How many chloride ions will be there? What will be this N? Tell me, guys. What will be this N? N कितना होगा? How many chloride ions will be present? 1, 2, 3, 4. First case के हिसाब से बताइए. You don't have to look at this at all. You just need to look here in order to say the number of independent chloride ions. Tell me.
1.
How many? 1. सबको दिख गया? Yes or no? Please tell me.
Yes, sir.
Okay. What about? Okay, fine. Once you have got this as 1, so 1 chloride ion is independent. That means you have something inside the square brackets. Okay, and there is 1 chlorine atom or 1 chloride atom ion that is outside the square bracket. So inside the square bracket, you will have cobalt. And how many chloride is remaining? Tell me. How many chloride ions are remaining?
2.
2, right? And how much NH3 is there? There are 4 moles of NH3. है ना? तो इसको इस तरह से लिख देंगे. Okay, so the only information that we have is about this chlorine atom, and it is given by the AgCl precipitated. The number of moles of AgCl precipitated gives you the number of chloride ions which are independent. And if you have one chloride ion which is independent, you remove that from the equation, and then you write everything inside the square brackets, and the rest of the chloride ions will be outside. All of you understood how to write the formula? Yes or no? Tell me from the given information.
So can you explain again?
How to write the formula? Did you get it? Yes or no? Please tell me. Yeah, sure. What is the first thing that you're going to do? You're going to find the number of independent chloride ions, right? Once you have found the independent chloride ions, you will write that. First case में क्या था आपके पास? In first case, you have 1 chloride ion that was independent. Not 3, no. Independent. How many independent? 1 chloride ion independent, right? And then we had the central metal atom was cobalt. So cobalt will be inside this coordination sphere. Then how much chlorine is remaining? 1 is independent. How much is inside or bonded to bonded to cobalt atom is 2 chlorine, right? And how much NH3 is present? 4 NH3 molecules are present. दिख रहा है आप लोग को नहीं दिख रहा है? So please tell me.
Got it, sir.
Got it. Now the secondary valency is equal to, we have 2 chloride ions and 4 NH3. So 2 plus 4 will be equal to 6. Okay, so these are the information for the first one. the formula and the secondary valency. That's the only thing that you have to find. Please send the answer for the second, third, and fourth and fifth.
सर ये सेकेंडरी वैलेंसी ऐड अप करते हैं क्या अंदर
जी
के
जी
मॉलिक्यूल्स में?
हाँ करेक्ट 2 moles of chloride and 4 moles of NH3. Then the second one, yeah, very good, correct. Third one, nickel, yes, very good, correct. Fourth one, PT, yeah, very good, correct. And fifth one, yes, correct. Very good, Zen. All of the answers are correct. Zen, it's fine, you can leave. Okay, thank you, bye-bye. Sahel, looking at your answer now. Second one is, wait a second. Yeah, second one is correct. Third one, correct. Fourth one is also correct. Fifth one is also correct. Very good, Sahil. You can also leave now. Thank you. Bye bye.
Thank you, sir. Allah Hafiz.
Allah Hafiz. Assalamu alaikum. Samira, looking at your answer now. Second one, oh, 4+1 क्यों किया आपने समायरा सेकंड वाले में? Samira, can you please send your mic on?
Yes, sir.
Why it is 4+1?
It should be only 4.
It should be only 4 now.
Yeah, yes, I got it.
Got it. Okay. Same for the third one. Fourth one is fine. Fifth one is also fine. Okay. Just correct those things. Ahmed and Jiva, waiting for your answer, guys. Ahmed and Jiva, waiting for your answers. What happened, Ahmed and Jiva? Please tell me. Are you stuck? And now it is correct, Samira. Actually, you are sending. Okay, okay.
I have
Jiva.
sent it, sir.
Actually, you have sent. Yeah, received it. First one. Once again. Second one. How many independent chloride ions? Jiva, tell me.
So
How
two,
many?
sir. So I two.
Two,
So
na?
it will be 4. Just 4.
It would be 4, right? You have to correct
Yes,
that.
sir.
And also inside that compound, inside that formula, PD, and then there will be only NSC and there will be no Cl there. Then you
Okay, sir.
have fourth one is fine. Acha, third one you have corrected it later on. Okay, okay, saw that. But in the third case now that you have corrected in the later part, nickel H2O. Oh, third part is nickel H2O. Second part after has to be put. Okay. H2O whole 6. And then there
Yes,
will
sir.
be 2 Cl, na? Cl2 will be there, right?
Okay, I should put 2. I should add 2.
Cl2, yeah. Cl4 in HCl1 is fine. And there is 2 NS3 here, right? You've just written NS3 all thrice type of thing. You see the mistake in the fifth one?
Yes, sir.
And it will be what? PT,
It's 2. Yeah, it's 2. Okay.
PT, Cl2, NS3 whole twice. And also it will be PT. You have written just P. So take
I
care of
was in a
those
hurry
small
to fix
mistakes.
it. I'll
No
correct it.
problem. You will just correct it. Okay. So it will be 4 secondary valency will be 4. Please correct it. Ahmed,
Sure.
waiting for your answers now. Samira and Jiva, if you want, you can leave now. Okay. Bye bye. Take care.
Thank you, sir.
Thank you, sir.
Thank you.
So once again, sir, sending.
Please send.
So I have sent you the.
Just received it. Oh my God. आपने देखिए कैसे भेजा है?
Yes, sir.
Can you please resend it? The second one is not clear. Like PD, NS3, whole 4. That's fine. Secondary valence is fine. Nickel H2O, that is also fine. PT, that is also Cl4. Yeah, 2HCl, that is fine. Correct. What about the last one, fifth one?
Oh, sorry, sir. I didn't honestly. So for PTCL2, right?
It will be PTCl2 and NS3 whole twice.
Yes, sir. The secondary value will be. Is it 4?
Yeah, 4. It will be 4. Yeah, correct.
So do I have to send the whole thing?
No, you don't have to send it now. Okay.
Okay.